Up here, time runs faster. Two identical atomic clocks start in sync. One inside a weathered shack at sea level. The other strapped into a ski plane, climbing 3,000 meters into thin air. 24 hours pass. The plane returns. On a snowfield above the clouds, one clock is checked against its twin far below. It reads 29 billionths of a second ahead. Proof that gravity doesn't just pull at matter, it pulls at minutes. A pocket watch never shows the trick, yet every phone tap, subway swipe, and rocket burn whispers the same secret. Your watch is lying to you, politely, by fractions that bend the world straight. The pilot pockets a small stone, souvenir from a place where noon arrives, a heartbeat late. For centuries, time looked absolute. Sundials, pendulums, railway whistles. Then 1905 arrived. Einstein declared simultaneity an illusion and showed clocks tick at different rates when they speed or climb. In 1971, jet-borne atomic clocks proved it. In 2015, quantum clocks detected a 2-centimeter altitude shift. Today, the 31 GPS satellites above your city correct 38 microseconds of relativity each day, so the blue dot in your pocket lands on the right street instead of the next town. Time is elastic, but engineering insists it keep appointments. Bern, 1905. Einstein, junior patent clerk, pictures lightning striking both ends of a moving train. Trackside, flashes look simultaneous. On board, the rare bolt reaches first. Simultaneity, he concludes, depends on velocity. He sketches a warped grid. A tram bell clangs below and rattles his coffee. The street colliding with the stars. Later that evening, he tells his violin partner, if you could race a beam of light, time would bow like a cello string. She laughs, missing a note. The melody bends, foreshadowing space-time's future curve. Special relativity is born, trimming Newton's certainty with one rule. Nothing outruns light. High above our heads, cosmic rays smash into atoms, spawning muons, unstable cousins of the electron, born too high to survive the fall. Their half-life is 2 microseconds. By Newton's rules, they should vanish in the upper atmosphere long before reaching sea level. Yet detectors pop with tracks. Something's off. Until Einstein steps in. From Earth's view, the muons' clocks slow down. From the muons' view, Earth's air flattens to a blur. Time stretches, space compresses, and suddenly, the math allows what intuition forbids. At dawn, lab TA Elena tapes fresh negatives to her window. Sunrise reveals silver streaks, like meteor showers trapped in glass. Some miracles aren't carved in myth. They flare for an instant in a cloud chamber. Each semester, high school students replicate the stunt with dry ice and a Geiger tube, proving relativity in hallways that still misjudge the morning bell. October 13th, 1971. Pan Am 707 arcs east, cesium clocks humming beside passenger knees. Stewardess hands physicist Joe Hafele peanuts and asks the experiment's purpose. He replies, "We're timing the planet." After circling the globe twice, Hafele and Keating compare airborne clocks with stay-home twins in DC. Eastbound loses 59 nanoseconds, westbound gains 273 nanoseconds, matching relativity. Newspapers shrug at nanoseconds. The machines that depend on them will not. From a few drifting billionths, we learn that motion changes time. And by moving, so do we. 4 atomic clocks orbit 20,200 kilometers above you. Up there, gravity is weaker, so they tick slightly faster, about 45 microseconds a day. But they're also moving fast, and that slows them down by 7 microseconds. The two effects don't cancel out, so engineers bake in a 38 microsecond correction before launch. The clocks are preset to tick slow on Earth, so that in orbit, they add up to perfect Earth seconds. In January 2016, one satellite drifts 13 microseconds off. Toronto ATMs crash. Digital radio pages go mute. First responders scramble with paper maps until the relativistic patch uploads. At a cafe, commuters curse phones that insist they're blocks away. Latte phone cools while physics is debugged. Miss the tweak, and your blue dot drifts 10 kilometers in a minute. An entire neighborhood lost in arithmetic. Boulder, Colorado. Inside a vacuum chamber, 2 optical lattice clocks sit one atop the other. Height difference, 2 centimeters. After hours, their ticks diverge because the lower clock feels Earth's pull a whisper stronger. Time now resolves altitude, not just hours. It ticks differently, 2 centimeters apart. Researcher Priya Mukherjee says these clocks could tell whether she's sitting or standing. That's how sharp they are. Tomorrow, these clocks may map subterranean magma, audit aquifers, even detect passing gravitational waves, too low for LIGO. The next discoveries won't be dug from the ground. They'll be read in the quiet ticks of a clock. Listen to your pulse. Feel its insistence. The beat is local, loyal, but not universal. Time stretches on airplanes, slackens on mountains, sings slower near black holes simmering at the hearts of galaxies. Each elevator ride, rocket burn, or navigation update is a quiet compromise with curved space-time. Some night, glance at your phone's map and imagine the satellites chanting math across vacuum, shaving microseconds so pizza arrives hot. Seconds obey geometry, not calendars. They bow to velocity and altitude, then spring upright inside wristwatches that pretend nothing happened. The universe whispers. In stones that count the days, watchmen in the sky, and explorers who drag time up mountains just to hear it breathe.